Tuesday, still the first.
Happy New Year, ladies and gentlemen. This is Diamond from the Oppenheimer Ranch Project. I have my leak project hat on, 5G, and we have William Wetstein, the legend of legends, student turned colleague, who was also turned my enemy moments ago, even days ago, because of the Douglas vote controversy, which he was unaware of my position on. William, how the heck are you? Good to have you on the show again. Happy New Year.
Happy New Year to you, Diamond. Great to be back. We got a lot to talk about today.
That's the understatement of the century, I would think.
Yeah, it is.
So, how was your New Year's? What'd you guys do last night?
And, just danced down a couple blocks and hung out with the crowd, and I actually got a little work in. There's some general interest out there in the population about weather and what's going on, particularly weather. Everybody notices weather, so there were some pretty good conversations in that front. Came back home and had a little fun. How about you, man?
Well, we got snowed in. We got snowed in. So I haven't seen Leah in 48 hours. We spent New Year's apart, but she's only like 10 miles from me, but it's too dangerous for her to even get out. And they just dug out tonight. There was a huge berm that the county had put right in front of the road where she lives. But all things are looking good. We're going to probably see each other first thing in the morning. She can get out there. Their pipes are frozen, so they're dealing with the frozen pipe issue tonight. And I just came in from outside. We've been talking, and it's snowing again. There's like over a foot out there. There's more dumping. It's crazy. So we're going to talk about...
Play it safe, man.
Yeah, we're going to talk about Doug Vogt and all of his amazing theories in his books. This guy's been around since the 70s. He has some high points and low points. But a lot of people are concerned about how this plays into the whole magnetic reversal idea. Now, you and I have no background in magnetic reversals, except that I'm a stratigrapher, and I know about the magnetic reversals. But we really didn't use that as part of our model, did we, Bill?
Nope. We, despite the fact that there was these nice little diagrams right on the geologic timescale about magnetic polarities, and we just ignored them, pretty much.
But the other guys, the structural geologists and all those people, they cared about magnetic reversals. We didn't, because we came up under Peter Goodwin and E.J. Anderson out of Temple University. And back in the 80s, this is Goodwin's paper. You can see this. This is the 85 abstract, Bill. You can see it, right?
The best of the lot.
Now, in
my opinion.
So this is our science. We learned, according to the hypothesis, which is the PAC hypothesis, P-A-C, PAC, like pack your bowl. The PAC hypothesis. According to the PAC hypothesis, punctuated aggradational cycles. Let's break it down in English. Punctuated. Boom! They happen immediately. Aggradational. The sediments, they aggrade, there's subsidence happening, and the sediments pile up. And cyclic, cycles. So these punctuated, boom! Depositional cycles, or PACs, were what we studied. And after we studied them for years, Bill, what is your impression of the theory? Did we find these PACs everywhere, or were they nowhere?
I do believe that it, and again, they're not going to be everywhere. And I think certainly in respect to Pete and Andy's work, we were very much concentrated on carbonate environments. And I think that needs to be pointed out. We can't just go into any water environment and expect to necessarily pick up this signal. So that part of it, I thought was, and that was stated right up front, wasn't hard to do. But yes, in the rock record itself, and again, you got to get out there and do it. We talked about this last week, and you have to be willing to go out there and look at it. A computer is not going to show you this necessarily.
Well, yeah,
you can certainly use it to extrapolate things.
We're going to show it to you. And I'm just going to go, boom! Watch this. So, Bill, you just said that you can't find these cycles in a carbonate environment. What we're looking at here is 4,800.
No, I said we did.
We can't find them outside of it. This is 4,800 feet of sandstone. There is no carbonate here. Do you see the PACs over here, Bill?
Yes. Yep.
Yeah,
well, maybe. Maybe.
How about over here? Do you see him over here?
And now we're getting warmer.
Okay, so the point
I
is
like
this, that if you go into the Grand Canyon, you can see punctuated aggradational cycles from the Cambrian through the Devonian, the Mississippian. Look they're called stripes. If you're a layman, look for the stripes. These stripes are what we're talking about. And what we have is two different unique depositional environments, one laid over the other. And there is a boundary between the two. And here is the atypical PAC. It's about 3 feet thick. Now this 3 feet, according to all of our research, represents about 26,000 years, give or take. And that there's two unique environments in a PAC. So there is one facies model.
That is.
And then there's a second facies model. And a facies model is just a depositional environment. And in this case, what you're looking at is these mud-cracked dolomites, which are over on the shoreline, shallowing into an estuary, which would be like the coastal plain in New Jersey, because there's like fossil mammal bones up in the shale, which is like on shore where the animals were up in the peat bogs. So this is a estuary, and this is the ocean. So the PAC itself has an abrupt boundary, boom, right here. Let's look at this line, where it goes to ocean environment, where you can see mud cracks here, and then it shallows up into the estuary. So that's what the PAC model basically is. Now, why I want Bill on tonight is to discuss the transition from this hypothesis back in 85 and modern thought. So this is the paper that came out in the Journal of Geology in 85, Punctuated Aggradational Cycles, the general hypothesis of episodic stratigraphic accumulation. And when we went in the field, we found it everywhere. Almost all environments that are sedimentary have these cycles. And it is...
And
go ahead.
And our job was to chase them. And I think we got to premise that with the alternative model at the time. It still may be, I don't know, that these were construed as diachronous boundaries, one formation to another, essentially migrating over each other. I mean, all using the same mechanisms to do that we were using, but what we're suggesting is that the boundary cuts across for traditional. When you read a formation, you'll read it a million times. If you go into this stuff, you'll see such and such formation, such and such formation. that is based on a diagonal boundary. What we're proposing is that boundary cuts through that, meaning if there's a tidal flat environment here, it doesn't mean that on the same plane there can't be a swamp environment over here. Both operating at the same time and under the same mechanisms. That's what we're trying to suggest here, because you see that word formation a lot if you look at this stuff, and we're a little cutting edge on that, I'm afraid. It's just not their tradition, unfortunately. And that was what Pete and Andy were proposing, as this is a basic stratigraphic interpretation of accumulation of sediment in a nutshell.
Well, Bill, which is why I've blown up this picture.
Boundary.
So what I want the audience to absorb from this sedimentary environment here is that what Bill and I were taught was that these layers are not continuous. They pinch away, and they go away because they're localized sedimentary phenomena, which is totally ludicrous.
Autogenic.
Yeah, because if you look
processes.
at this picture, these layers are, I mean, they're almost like a clock. They go, there's no change. And what we're talking about is not the specific material between the boundaries themselves, the actual boundaries between the colors. Those lines extend forever. And one in question, I can prove it to you, Bill. Come over here. Left side of the picture. See the dark brown down here? Let's travel along it laterally, because if we're walking along the earth, this dark brown sedimentary environment will change. And look, it pinches here, and then it comes back, and it gets thick again. But watch what happens to the right, Bill. It goes away. It's missing. But the boundary here between the brown and the white, it isn't missing. It keeps going and going, and it's down here, and now we're at the beach. So we just went from the estuary where the brown mud is back to the beach. Look at these big dunes, and it keeps going. These boundaries go forever, and that was what our job was, to actually follow the boundaries and not the sediments.
That's right. That's exactly right. And just to, how difficult that was, even just to relay that to the audience, that Dave and I could go out to the same outcrop and we could both disagree. What's what? But what I'm trying to point out there is it's really important to not look at rock the way we're looking at it on this program, to get up there and actually look at it. The arm weight, and this probably goes out to any of the potential geologists or any geologists that are interested in this and want to get into this, get your face up there and ID the rock, because that's really the basis of this. It's great to see these neat little lines, but if you don't know what you're looking at, then it doesn't help the hypothesis. And again, it may still be a hypothesis. I'm not sure. I like to think it's a theory, but it's not.
So the hypothesis is simple. It's that sedimentary environments were laid down as units, layers that go forever around the world, and they can be correlated. That is the PAC hypothesis. And now we're going to add a little bit of esoteric information onto that. But first, I want to make sure that everyone knows that the paper was in the Journal of Geology, what we're talking about, in 1985. It is still referenced today. The idea has been stolen and rehashed by other scientists, but we're gonna try to roll it into Milankovitch and the idea of Micronova, which is coming out from Douglas Vogt, because here's the problem. When you get into paleooceanography and paleoclimatology and the implications for PACs in stratigraphic analysis, if we're talking about Milankovitch, now the Milankovitch cycles, basically what they they say, and we'll do a little primer right here, Bill, for the audience. The Milankovitch cycle is based on mathematical calculations of the orbital perturbations that Milankovitch in the 40s calculated to be true. Now, this is based on Newtonian physics, gravity being a constant, and this, that, and the third. So when it comes down to these variations, there are problems, because the main problem we had in academia was there's different time scales. Is the Earth, the top, wobbling here? Is it slowing? Is it going faster? Why are there different dates for the tilt and the wobble? Well, I can assure you that the ancient man knew that the precession of the equinoxes occurred. I can assure you that. It's where astrology comes from, Bill. And I can also assure you that geologists and esoteric scientists have been working on this for decades. Graham Hancock, Randall Carlson, to name a few. We're looking at Randall Carlson's great year, cosmic catastrophe clock. And this is the cosmic clock. Now, the blue dots are all corroborated geologically from peer-reviewed papers. These are events that are associated with glaciation, Bill. Now, here's the problem. We're about to go real deep here because I'm going to blow it up right now for the audience because they need this. Douglas Vogt thinks that this 12,068-year cycle has been happening again and again and again. Have you watched enough of his stuff to agree with me there?
I think not as much as you, but yes, generally it looks like he has, one defined principle.
Yeah. So if
and
you
he's
look
running
at
with it.
look at this outcrop, Bill, I could believe Doug, couldn't you? Every white and
Yes.
brown line is a magnetic reversal and a catastrophe, and it's repeating like a clock. That looks like a clock to me, doesn't it?
Right. Yes.
And
just before we go ahead.
We're field geologists, so I want to hear what you say, because that, to me, is proof that Doug's right.
Right. And I mean, yes, there is, and I'm sure you have a dozen examples of, yes, that 100,000-year signal. Regardless of the PACs below it, we can get into that as we go along, but there is a defined 100,000-year signal.
No,
and
Bill, you're jumping
to,
forward. Listen, these stripes each represent
okay.
a precessional cycle. So what we're seeing here is Doug's cycle, the 12,068-year cycle, every stripe. Boom,
Okay.
boom, boom. So in this picture,
Okay.
Doug would be right. Correct?
We got you. Yep.
And this is the cosmic year that Randall Carlson created. And this is geology for the last 150,000 years laid upon it, where we can see Heinrich events, the Greenland Blitz, the onset of the late Wisconsinian, all on the line that we're now living. So we're the next blue dot right here is today, right here, which is the onset of the next ice age based on evidence for the last 100,000 years. And exactly halfway back, which is supposedly the magnetic reversal, called the Gothenburg, which is also the end of the Ice Age. This is the warming event, corroborated 1, 2, 3, 4, 5 times, 117,000 years before present, 65,000 years before present, 39,000 years before present, and 12/9, the event we all know about, when sea level rose 400 feet, the Clovis people were inundated, and all of the flood mythology evolved from. Now, to add insult to injury, there is a midpoint catastrophe on the cosmic year where we can see other events happening. So that is why this Iron Cross great year, and you can see inlaid in the center here, astrology, is now being corroborated and correlated with ancient mythology and modern science. I mean, the PAC hypothesis alone and the pictures that we can show you that are undeniable of this cycle that is continuously happening again and 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 again. But what we want to get to is it's not a clock. It's not a regular clock, because let's be real. I want you to be an artist now. Let's be a pragmatist. Let's look at the beauty of nature. Let's look at the rock. Let's look at the cliff. There are cycles within the cycles. And this is what Peter Goodwin and I talked about at length every time we drank too much scotch and played too much pool. That these cycles are layered upon themselves in a nested hierarchy, a dance, so to speak. It's almost a cosmic resonance. If we could make a sinusoidal wave here on the color pattern, you could see the nested hierarchy emerge. Some areas, there's whiter areas. You see black patterns every fifth here, and then they get closer. And then there's whiter areas here, here, and here. There are so many ways. Look at these far apart over here, white stripes. You and I, Bill, know that these far apart white stripes are probably fourth order cycles. You know, these are 400,000 year cycles, maybe 2 million year cycles, because we know that this nested hierarchy of cycles exists. Boom! And let's get to the data. Because I think a lot of the pieces missing from Doug Vogt's work and others is the facts. And we only deal with facts. We are field geologists. We go and we taste the rocks, we smell them, and we hammer them, and we roll in them. And then we also revel in the other proxy data. Now, this is the Vostok ice core. So we can go check the rocks out in the quarry, Bill, but then if we can match it with what's happening in the ice, then we have correlation is not causation. We know, but we're trying to explain the hypothesis, which to this date, the PAC hypothesis holds true. Those cycles are everywhere. Now, the problem is the mechanism. We were always looking for a mechanism. So before I bloviate about Micronova, glaciation, and the truth, we didn't rehearse this at all. You don't have a script. When we got the PAC hypothesis, 20 years ago, what was the mechanism that we were told was the mechanism?
Well, the primary mechanism was always glaciation. And we've gotten a pretty good idea that it just doesn't seem like it can be. It doesn't seem like it works out.
Why do you say that?
Because you can, it shows up in this graph. I mean, you have too high a temperature to, generally speaking, to just be on a 12,000 year cycle, constant glaciation. We just couldn't. That part of it doesn't agree with it. So you either revise or throw it out. You'd have to revise your method of where another mechanism. It would have to be.
Yeah, because, and let me just bring people back. Here we're looking at carbonates. These are very old. These are Devonian or Silurian carbonates. I know simply by the fact that they're wavy and they're deformed a little in this region. This could be in Germany. It could also be in the US. But these types of Devonian carbonates are old. And there's also evidence in this here. We're probably in the Permian here, or somewhere in the middle Carboniferous, up in maybe the Grand Canyon region with these. And here we can see all the way from the Cambrian through the Permian, this layering. Now the problem is during the Mississippian and the Pennsylvanian, this is where all the coal measures are. I mean, we had like ferns that are purported to be 800 feet high. Lepidodendron forests. Plus, I mean, none of it makes sense for a number of reasons. Because if this was truly the environment on Earth for millions or tens of millions of years, there was no glacial ice. So if we have no glacial ice, then what's driving these layers? So if we can say geologically that there was glacial ice back here and that we're getting the layers from Milankovitch and the ice growing, right? Glaciers build, sea level drops. Glaciers melt, sea level rises. On and on and on. Boom, boom, boom. Da, 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 da. And here we have the Milankovitch cycles and temperature from the Vostok in the recent past. This is going back 250,000 years. This is with the eccentricity and the precessional cycle laid on top of it. So each of these peaks and valleys is a 26,000 year precessional cycle. And the pink graph is assumed temperature based on proxy data. What I mean by proxy data is the CO2 data from the ice cores and the methane. So we have CH4 every millimeter from the Vostok and CO2 because we sample it, do a mass spec, and we get these graphs. And then from the proxy data in blue and green, we get the red, assumed temperature. And temperature always follows CO2. There's a lag, which means that CO2 doesn't drive temperature. It means that CO2 is a factor of temperature. So that kills the global warming hypothesis right from the rip here, about 320,000 years ago. This lag proves global warming is not real. And another thing proving global warming is not real, Bill, here is the blue line, which is CO2, now leaving the planet. Do you see it over here? And the temperature is not. The temperature's not leaving the planet.
You got to pull the page down a little bit.
Because the temperature's dropping.
Right.
So the mechanism is not glacial. But maybe Milankovitch is driven by the mechanism. What do you think about that idea? If the mechanism is what Doug says is called the dihold, what if the dihold is emanating from the sun? Wow, wow, wow. And sometimes, but it affects the wobble. So the wobble of the planet is because of the dihold. But it's not always glacial. But what always happens is a catastrophe here. We know that geologically. Whoa, what was that? Man, I'm trying to get to my graph. There it is. But what I want to point out here, this is the most important graph in history, the Vostok data. And do you agree with me that this is a pretty important piece of evidence, Bill?
Certainly for the recent past. I don't know of, I personally don't know of any other source out there that could, and I wish we had more, obviously. But with all these pieces, particularly the solar insulation, I think that's the big key with this. because that's kind of what we're talking about here. By and large, is that one thing is going to pretty much drive the rest of it.
So
So when that agrees,
solar insolation, Bill, is the brown here, the top brown graph, and
correct.
and that corresponds to this smooth BS version, but there is definitely here you can see that the sun clearly is correlatable to the temperature. No one on Earth could claim anything otherwise, yet they do. So this is very important information proving that natural climate cycles are natural and they have nothing to do with man. And if you think that man has anything to do with natural climate cycles, please look at this wall.
And if you go back to the other one, you will see that yes, do you see a lot of change in that environment over all that rock? The other one, even that one to some extent. Yes, so that one there. I mean, those environments one after the next are, they're not all in the PAC sense. They are drastically different, but you're looking at a lot of similar environments there, a lot of sensation.
A lot of similar environments
base level
repeating
stability.
itself. It repeats it again and again and again for millions of years. It does not stop.
That's why it looks the way it does.
Brown, white, brown, white, brown, white. Now, I'm going to blow your mind.
Just to allow. Hold on a second, and before we get away from this, but I just wanted to point out that in the field, when we're looking for these particular PACs in any type of rock, and this is a great example, we're looking. Say, take any one line to the next one. We're looking for that pattern in something else. The way that pattern is hitting, whether it be 3 white lines or 2 white lines or 5 or 8, we're looking for that kind of pattern somewhere else. Now, it may be 6 somewhere else, but there's always going to be a definable boundary somewhere to box that all in.
Yeah, the patterns were the key.
It's the patterns. That's what we're looking at.
Now I want to blow some minds here. I'm a paleoclimatologist, which means I'm a paleontologist. I'm an invertebrate paleontologist. That was my schooling. I learned about 90% of all the life on Earth, which are the non-vertebrates. Brachiopods, clams, and Bill knows I knew a lot of them, especially all the fossils in the areas I would go study. But I want to blow your mind because back in the 90s, Niles Eldredge came out with the idea of punctuated equilibria, which that hypothesis started in the late 70s. And the reason was because, and Bill knows it, in my paleontology class that I would teach when we were learning about fossils, there are no transitional species. You have these trees and these lines, and then new species above these lines. So one of the most astounding things I can point out to you, which Bill was pointing out, an opposite thing. We have millions of years of the same sedimentary environment here, going from deep to shallow, deep to shallow, deep to shallow. The environment is never changing. The shallow one is the same and the deep one is the same. They're just repeating different amounts and different thicknesses. Would you disagree, Bill?
No, I wouldn't. That's
millions of years of the same environments shifting. Now, if we were to lay the paleontology onto this, your mind would be blown, because what you would see is that there is a brachiopod that only lives here in this brown unit. It starts at this layer and it ends at this white layer. This is the only layer that brachiopod has ever lived in. It might only be 400,000 years, but it is the only species that is that species, and that is a marker bed. And that will be correlative basin wide, hundreds of miles in every direction. But directly above this layer, there is no more of this species. After a 500,000 years, there's a completely new species. And that one goes all the way up to this white bed. And that's all of the time that that species lived. In the same sedimentary environment, we have this species and then a completely new one. And again, and again, and again. Over and over.
Right.
No transition. Just replacement.
Nope. As Niles pointed out very succinctly, it wasn't a struggle for survival of the fittest. It was the struggle for the most sexually successful. Regardless of what their defense mechanisms. I mean, Stephen Jay Gould spent an entire career talking about this. Just not to digress, but look at the kiwi bird. I don't think you'll ever find a more lumbering species in your life, but why did they survive? It's all about your environment, as you pointed out.
Yeah, and the environment changes again and again, very violently. And if it is Milankovitch related, if there is a diehold, we know that the sun here, this is solar insolation, is the main driver of temperature. Now, what you're looking at here, Bill, is the last 250,000 years, where we get very good correlation with solar insolation, the Milankovitch hypothesis in blue, and the actual proxy temps. Now, if Doug Vogt is correct, if he's correct, what I did was I put right here down the bottom of this graph the last 1, 2, 3, 4 magnetic reversals that are peer-reviewed, basically geologically accepted, and they fall on his 12,069-year cycle. 1, 2, 3, 4. The most recent 4 we can correlate with modern science and papers that have come out in the last 3 decades. And then if you go past there, there's less data. And these purple ones that I put on here are the ones that graduate students have written papers about. But I think that there probably are magnetic reversals every 12,068, as Doug suggests. They're just missing because we don't have enough people studying that. And you know about the stripes on the mid-ocean floor. They're pretty regular and they happen all the time. And we do tons of studies. So there's definitely missing data on magnetic reversals. Would you agree with that statement?
Definitely. Now that being said, there is a wealth of stuff out there, and I'm certainly going to look a lot harder to see what I can find in that front. Certainly, but it seems like it's in its infancy a little bit because it really hasn't mattered. But in terms of what they're identifying as magnetic, even to that degree. And again, I think we got to be careful. This goes back to last week of how we're looking at things based on what we want to see or based on what's there.
Yeah. So let's talk about what's there. And do you remember, Bill, because I remember as a grad student and my mentors, when we were out there and talking about geomagnetic reversals, almost all of them said geomagnetic information's bullshit. It can be reset. It can be erased by any cosmic event at any time. So the geomagnetic information is limited at best.
Yeah, like I said, it's kind of like it's a lot to do with the sun. It doesn't get the attention that, to the extent that other things do. Say like the CO, for example, CH4, for example, that gets a lot of attention.
Well, let's talk about the facts that we know, because I want to have a really great conversation with Doug Vogt when we come on the show, and I want to have him listen to where we're at. If you add electric universe into our theory, if you add Milankovitch, if you add the whole conversation that we just had about our experience as field geologists. I mean, we know this cycle happens again and again and again. We also know it's modulated. You know, it's packeted. Here's 5 of them. Here's 4, 2, 3, 2. There's packages. We know that we can see these cycles for millions of years, hundreds of millions, all different environments. And if we just look at the most recent past, we can see the cycles here playing out on solar insolation. This would be causing sea level to change. So this would cause this is basically a sea level graph. And what I put on here was the great years based on the esoteric information, the information that comes out from astrology. A great year is each one of those things that we're seeing right there. Each of those 2 stripes. Each of these stripes is a great year. And they go on and on and on and on and on. But they're modulated. And if we come to the most crystal clear information set of proxy data, CH4, CO2, like you said, and we look at it the last 400,000 years, you can see how I put up here, this is, our work, eccentricity cycle in black. These are the 5th order cycles that we did back in grad school. These are the 5ths. And you can see that it's the 100,000 year cycle that is the most extreme. And the 12.9 is the same back here as the 120, same back here as the 230, and same back here as the 330. These are 100,000 year Milankovitch cycles. And I think that we don't have all the pieces. What do you think, Bill?
I would tend to agree in that we've seen pretty good data here and pretty good proof that, again, glaciers can't do it all. And that was, to their credit, that was the original driving force of the PAC theory, PAC hypothesis, I should say. That it just proves not to be the case. It just can't be. It just doesn't match up. So, and we're willing to accept that. He got us along pretty well, actually. So, I'm gonna give Pete a pass on that one.
I want to just throw this out here before we close up, Bill. I think this is a ton of information to absorb. But what I think I see,
it is.
What I think I see here, because the Doug Vogt information and the magnetic reversal information that has been, and the solar outburst, the mini nova information coming. Doug Vogt's not the first person. Robert Schoch mentioned it about 6 years ago. Robert Felix mentioned it decades ago, and others. This is just a recent rehash of it. But I think that there is Doug's idea of a diehold, of there being some dynamo that's going wow, wow, wow. That, I think, is real. I don't know if it's the 12,068 years. I don't see it in this data. I see about 100,000 year cycle. But look, Bill, look at this. There's a small 5th, and here's a longer one, and then this one's even longer. So this one's like 120,000. This one's like 100, and this one's like 80. Do you remember when we were talking about that decades ago in the field? This is exactly what the data suggests, that this nested hierarchy is in and out of phase. And what we are now uncovering for the first time is that there are many other layers. Milankovitch is one. And that maybe the micronova comes into play a lot here, because it's unexplainable right here why the temperature drops so quickly. Here, many places on this graph. So maybe there is a micronova that does happen, But the crustal slip and the major catastrophe in Chan Thomas's book, The Adam and Eve Story, I think if it happened, it only happens here on these big spikes, and that's 100,000-year cycle, and we just missed it. Because based on all proxy data, what happens in this cycle is it gets really cold really quick, but not instantly. It takes up to 1,400 years to drop 10C. In all of these first drop downs, and the one we're living is right here, it takes almost 1,000 years to lower the temperature that quickly, based on the data. I don't see any other evidence to suggest otherwise. Do you?
And no, and even at that, it's brief.
Yeah, it always comes back. It always comes back, baby. It's a cycle.
No, I don't. I mean, just to go back to the rock explanation in the field, and to explain what we saw, we always, when we saw, I mean, fifth order cycles jumped out at us because it was just a great, totally different sedimentation rate, sedimentology, fossils, the whole, everything about it was different than what was underneath of it. Total environmental change.
Yeah, and it might all look like the same rock, but it wasn't.
Right.
So, any closing words? Let's just run through here real quick. What we're saying is that there are many solar forcing mechanisms. The Milankovitch is a new piece of the puzzle. It is not the end-all be-all. There is not a crustal slip and a major catastrophe. There is no evidence for that in the rock record. There is evidence for a 100,000 year peak here, peak here, peak here. Major modulation. And it's in the rock record. Bill and I saw it. It was the fifth order boundary. Boom. Here's one. Here's one. Here's one. And the last one just happened 12,900 years ago, which means we're safe for probably 80,000 more years until the next fifth order boundary. Those are the ones that I believe maybe crustal slip, micronova, all that stuff that we're going to slowly be working on uncovering day by day as we move forward. No jumping to conclusions. We're going to go through these facts, charts, data, day by day, ad infinitum for your benefit. There are many modulators. This is just right here. Precession of the equinoxes, obliquity, eccentricity, that's the fifth order cycle. And then you can see it on the stages of glaciation down below here. It is clear that the fifth order cycle, boom, is the main, boom, modulator, boom. And it is not the 12,068 year magnetic reversal or any of that. These 100,000 year drop downs are when the hits the fan. Bill, anything to add?
No, I like the way you covered it. We will probably get into, I'm sure there are people wondering, how does all this sediment get stored, so to speak? How do we have access to so much sediment? I think that's a whole nother, but I can assure you it does happen, and we will go into it, and it is part of this. It is very much a part of it's not the driver, but it is the accomplice, if you will, to why we get what we get. And in that is another mechanism that we might need to develop as well. So, we got work to do, brother.
Yeah, so we're going to be talking about Milankovitch theory and climate moving forward and how it doesn't meet all the models, but it is a modulator. It's a huge modulator. It's provable, and it's provable on the benthic foraminifera, on the Vostok data, and the ice core itself. And I showed you the stacks overlay here. Correlation is not causation, but man has nothing to do with the sun matching the temperature change on Earth for 250,000 years. That has everything to do with scientific facts and analysis. We used to think the Milankovitch cycle was the driver, but ancient man is the key to more information. They knew about this cosmic year, the great year. That's where all astrology comes from. And many pieces of the puzzle are coming together. There is a significance to the boundary we're living on, and it is major. It is the onset of the next glacial period. Now, whether that involves crustal displacement in a micronova is to be seen, but it will definitely involve a magnetic reversal. And that's a boom.
We got to get one. Yeah,
Bill, thanks for joining us.
We got
Happy
a
New
lot
Year.
of work to do there.
I cut
Happy
you
New
off.
Year to you, brother. We'll talk to you soon.
We love you. Bill's going to be at LeCon
Love
2019,
you.
and he's going to have a special booth where you have to pay $10 to answer all questions, geological. All proceeds go to the magnetic reversal bunker that we're establishing at the center of the Earth.
We just need copper. That's all.
Tons of it. And gold.
Tons of it. Tons of it.
We love you. Be safe. Happy New Year.
Love it.